Hi, this is Jason here. Just wanted to give a quick business presentation of the capstone project that was assigned to us graduate engineering trainees at TVS by Analytics Vidya. So the problem statement here is forecasting credit card spends for personalized customer relationship management, and we were supposed to predict the average spend on credit cards of customers of XYZ bank, and this is how I approach this problem. So the context here basically is that accurate predictions of credit card spends and forecasting things like that is very important in a market context because that helps the bankers understand their clients better, like their spending patterns, seasonal changes, what they are expected to do, so planning their overdraft limits and things like that based on this. And obviously, so for this, we'll be working with a lot of data, including demographics, spending habits, things like that. And the problem statement here is to build a suitable machine learning algorithm which will predict this forecast based on all the data that has been given to us. So, and I will just go through some of the challenges that I faced while attempting this task. And as you can see here, we have data quality, feature complexity, and model selection, which were the three main challenges. So to elaborate a little bit more about these, basically, the dataset contains around 32,000 rows. So that's a sizable data, and obviously it'll have a few outliers, missing values, etc. So we during the exploration phase and the EDA, we'll try to see how we can manipulate those and make sure that we extract all the meaningful information from even the rows that have outliers without discarding them just like that, things like that. And obviously you have feature engineering, have to be careful with the if there is any kind of aggregation or data augmentation that needs to be done to get more better values for the prediction. So that is also another challenge that I undertook. And besides that, model selection as well, regression has plenty of options to go from. You have ADA boost, boosting algorithms, and random forest regressors like lasso, ridge, etc., things like that, and ensemble methods as well, like I mentioned earlier. So and what I've taken as an approach is was to stack the models and see how that compares. And yeah, so my solution here, as I mentioned, is a robust model that follows the ensemble approach to provide reliable results. So this would be combining predictions from multiple base models such as ridge, lasso, random forest, XGBoost, etc., and the scores are well below threshold on RMSLE, which is the evaluation criteria that was specified for this challenge particularly. And obviously, it can be exported as a pickle file using joblib, etc., and can be deployed as a machine learning model using libraries such as Streamlit or Gradio, etc. So a little more about the implementation. So basically, this is the stages, and we do data exploration, basically understanding what the features mean. We have been provided with a data dictionary Excel file which gives descriptions about each features and how it might be important to them is something that we can infer from these, and also with the domain knowledge that we have. Then we go with visualizing everything and seeing the outliers and thinking of ways to treat them and to decide the model based on these values that we are getting. And then we do feature engineering. Obviously, I have done some aggregation and taking sums of a few columns that have a lot of missing values, imputing them, etc. And then the actual model training part, and then the evaluation and stacking, etc. So the features, like I mentioned earlier, it has 32,820 rows and 44 columns, of which obviously like the ID and the target variable will be excluded later on. So yeah, we have numerical and categorical features as well. Categorical mainly focusing on gender and account type, whether it's current or savings. Besides this, we have demographic information and financial as well, like if the person has investments in DMAT, fixed deposits, insurance, etc., and then loan information such as personal or vehicle loans. Expenditure being the the more correlated part of the data set, contains credit and debit card spends and the credited amount, debited amounts, and the counts of transactions for 3 months. And that is what we'll be using. And here are a few visuals from the EDA part. You can see that there are bar plots of the target variable by gender, account type, categorical feature analysis, and then seasonal expenditure trends on the 3 months on credit card and debit card as well. And then we have a correlation heat map of the features after the pre-processing stage was done. And then here are some of the RMSLE scores of the initial models that we worked on. And this would be, I mean, we as in I, because it's a solo project, obviously. Pardon that semantical mistake. Yeah, so I went with these models and eventually decided to, stack them into a proper stacked ensemble model. And you can see the metrics here, the MSE, the MAE, etc. RMSLE value that I have gotten on the split training dataset was 1.11. And then online, as per the portal submission, it is around 116. So this is my presentation, and here is a very quick overlook on the notebook as well, which you can run and see for yourself. So you can see I'm just importing the packages, then doing some data exploration, checking out the shape, the descriptions of the features, information as to if things have to be imputed for them to be numerical, like encoding and things like that, checking out the correlation, several things like that. After that, some of the outlier detection in the values in the target variable, and then using age, and then removing these outliers in such a way that they don't affect them. With the box plots, we can see clearly where the outliers are. And yeah, so after that, it looks a lot cleaner. And then we will start to analyze the categorical features here, similar to the graphs that I showed you in the presentation. And then we start to handle the missing values. We impute them with 0, because a lot of times in this particular data set, values missing indicate non-usage. So basically, if let's say the debit card spent for a particular month was not included, that probably means that they did not use their debit card for the month, because they already have their credit card. So with that kind of knowledge, here is some more visualization of the missing values. And then we start doing feature engineering of combining all those investments, and then the active and closed loans, and then aggregating the expenditure, the previous 3 months average, and using that as a feature, which will give us a lot more information. And after this, we have that now the dataset contains 21 features. And proceeding with all of this, we start doing the one hot encoding or label encoding in this case. And after we do all of that, then we start training the models. So as you can see, we have Huber, Lasso, Ridge, ElasticNet, etc., etc., several regressor models. And then we calculate the RMSLE values for all of these, as you can see right here. And then we check out the scores and then visualize these. And as you can see, only a few cross the threshold actually. So after this, we start doing our stacking. We generate level 1 predictions using these previously trained models, and we take these features and then do a meta model. Here, since the Huber regressor was the one that performed the best, we use that, and then we see a slightly increased stacked model RMSLE, as you can see here, which is 1.2. And then we just repeat this process one more time, and we can see something like 1.17. So the final solution for this problem has, you can check it out in the solutions.py file. And that would be the end of this presentation. Thank you for watching.